Question 8. An anti-clockwise rotation centre at 0, 0 will map a point A onto point B. What is the angle of rotation? Angles of rotation are always either 90, 180 or 270 degrees. So you've just got to spot which one of those it is. You should be able to spot that to move that around to there is a turn of 90 degrees. If it was 180 degrees, it would move over into this quadrant here. The other way of doing it is if you draw lines from the centre, from the 0, 0 centre out, you'll see that it's pretty much a right angle there, so it's 90 degrees. Part B, describe fully a different type of transformation which will map point A onto point B. So the other transformations are enlargement, reflection and translation. It's not an enlargement and it's not a reflection, so it has to be a translation. And for every translation you've got to state the vector. So the vector says how many across have we gone? Well, we've gone 1 to the right and 1, 2, 3, 4, 5, 6, 7 up. So it's 1 to the right, that's positive, and 7 up. Part C, point A can be mapped onto point B by a reflection in a parallel line to the x-axis, followed by a reflection in a parallel line to the y-axis. Write down the equation of each of these lines. So, to get from B to A, we're going to reflect it first of all in some line that's going to move it to here, and then we need to reflect that point to there. So, in order to reflect B down to here, we'll have to have reflected it down some line in the middle. And seeing as though it's 1, 2, 3, 4, 5, 6, 7 points apart, it has to be 3.5 squares down. So the line that's been reflected in would have to be this line here. And that is the line where y is 0.5. Or even where y is minus 0.5. So that reflects it to there. Now we just need to reflect it in a line that we straight up here. So the line that this bit's reflected in will be this one here. And this here is where x equals 3.5. So it's now been reflected in the line x equals 3.5.